In this video, we are going to learn how to use the discriminant. The discriminant is that little expression underneath the radical in the quadratic formula, which is b squared minus 4ac. The reason why they call this the discriminant, because it helps you discriminate between different quadratic equations and how many real solutions they have. Now what that means is if b squared minus 4ac is a positive number, then we should have two real solutions. And what that means is that our quadratic, our parabola, crosses the x value twice. So we would have two x-intercepts as well. Now, if this number underneath the radical is 0, learned in a previous example, that would just be negative b plus or minus 0, just giving us one solution, which would be negative b over 2a. So this would be one real solution. What that looks like on a graph is whenever the parabola just touches the x-axis once and then turns away from it, giving you just one x-intercept. Now, whenever this number is negative, we have the square root of a negative number, which we don't know any number so far that when you square it gives you a negative number. So in this case, there will be no real solutions. What this looks like on a graph is when your parabola is completely above or completely below the x-axis, giving you 0 x-intercepts. Now let's put this into practice. So given this equation, let's evaluate the discriminant for the equation and determine how many real number solutions there are. So I have here negative 2x squared minus 3x plus 5, meaning a is equal to negative 2, b is equal to negative 3, and c is equal to 5. So if I were to use my discriminants, I would have negative 3 squared minus 4 times negative 2 times 5. This gives me 9 plus 8 times 5, which is 40. Give me 49. Now, since that is a positive number, it's greater than 0. That means I have two real solutions. There's your discriminants, and this is how many real solutions we have. So that's simple. I can already tell that I will have two solutions without solving the equation. And if I wanted to go ahead and solve it, I now know the number that just goes underneath the radical, so I can skip that step when solving. Now let's look at the next one. We have 2x squared, which means a is equal to 2, minus 3x, which means b is equal to negative 3 again, and then plus 7, which means c is equal to 7. So here I'll have negative 3 squared minus 4 times 2 times 7, giving me 9 minus 8 times 7, which is 56, giving me negative 47. So this is a negative number, so we'll have no real solutions. Now, how could this be used in like real life? Well, let's say, for example, you hit a golf ball into the air from a height of 1 inch above the ground with the initial velocity of 85 feet per second. The function h is equal to negative t squared plus 85t plus 1/12 models the height in feet of the ball at time t in seconds. Now, will the ball reach a height of 115 feet? So now I can use the discriminant just to know if it's possible to even get that high of a hit with the way I hit a golf ball at 85 feet per second. So the way I would set this up is I know the height is 115, so I'll replace h with 115. It'll be equal to negative 16 t squared plus 85 t plus 1/12. I'll subtract 115, give me 0 is equal to negative 16 t squared plus 85 t, and then 1/12 minus 115 would be minus 114 and 11/12. So now I want to find the discriminant, which would be b squared, which would be 85 squared, minus 4 times a, which is negative 16, times negative c, which is negative 114, and 11/12. Now, to plug that into my calculator a little bit easier, I'm going to figure out what this number is, 114, negative 114, 11/12, which would be negative 114 points. 11 divided by 12, which is 0.916 repeating, so 917. And I plug this in, 85 minus 4 times negative 16 times negative 114.917. I get negative 7,269.688, which means that since that's negative, I will have no real solutions, meaning that no, the ball will not reach a height of 115 feet. So in that case, I don't have to figure out what time it would hit that height, because it's never going to hit that height to begin with. Now, let's see if it could reach a height of 110 feet. So I have 110 is equal to negative 16 t squared plus 85 t plus a 12th. Subtract 110, I get 0 is equal to negative 16t squared plus 85t minus 109 and 11/12. Which when I plug it into my discriminant, I get 85 squared. I'm realizing I never squared the 85 earlier, so this number is probably different. Let's figure out what that number would be. So I get 85 squared minus 4 times negative 16 times negative 114.719. It's still negative, just much smaller. It's negative 117.016. Still negative, so no, the ball will not reach that height. But now let's try this. Do this one down here. We have 85 squared minus 4 times a, which is negative 16, times negative 109 and 11/12, which is negative 109.917, as we figured out earlier, which would be approximately 202.984. Now let's say positive discriminant, so yes, the golf ball will reach a height of 110 feet. So again, I never really had to solve. I just had to learn if I could, and it can. And that is how you use the discriminants.